Hey there, welcome back to the channel. If you are just joining us, make sure to check out part 1 where we built our foundation databases. That's essential for following along the journey. Today, we will start writing the code for our MCP server. In this aspect, we will begin with creating the database manager class, the core component that will handle all our database connections and operations. In this part, we will focus specifically on building the foundation of our database manager that can connect to both SQLite and PostgreSQL databases. It can handle connection testing and error management, and it can also cache table schemas for better performance. We will walk through each method step by step, understanding the logic behind database initialization, connection validation, and schema retrieval. So let's dive right into the code. Now that we have created and set up the database, it's time to start building the MCP server. And to do that, first we will create a file name database underscore MCP and .py. And first we will import the async input output library. And to do that, type import async input output. Async input output. Imagine a waiter who can take multiple orders, serve different tables, and process payments all at the same time without making anyone wait. And so this is about async input output library, and then we will import the JSON library. So here we are importing the JSON library because every response from our database server will be formatted as JSON, making it easy for other programs, including AI system, to understand and process our data. It is like having a diplomat who can speak every programming language. And then we will import the SQLite library. It is a Python's built-in SQLite interface. It is a master key for all the SQLite database files, and we have already worked with this before while creating the databases. After this, we will import the OS library. The OS library in Python is a built-in module that provides a way of interacting with the operating system. It allows us to perform common system level operations like working with the file paths, creating, deleting, and modifying files and directories, accessing environment variables, running system commands, navigating the file system. After this, we will import the regular expression library. The RE library in Python is the regular expression module. It provides a powerful way to search, match, and manipulate strings using patterns. It is used for searching for specific patterns in the text, validating strings, for example, in email IDs and phone numbers, replacing substrings and splitting strings based on patterns. Next, we will import the path class from the pathlib library. So let's do that. Type from pathlib import path. Pathlib library is a standard library module in Python that provides object-oriented tools to work with file system paths. Instead of handling paths as plain strings, pathlib lets us use path class objects which come with methods and properties for path manipulation. And then we will import some classes from the typing module. To do that, we will type from typing, and then we will import list, dictionary, any, and then optional, and then we will import union. So with the help of this typing module, we are importing the data type hints, which helps us describe the types of variables, function arguments, and return values in a clear, structured way. This is useful for improving readability and maintaining large code bases. And now we will import the asynchronous context manager from the context clip library. Type From context lib, then we will import async context manager. It is used to manage resources that need setup and cleanup, such as database connections, WebSocket sessions, and temporary files. And after importing this, we will import the asynchronous iterator. And to do that, type from collections.abc, and then we will import async iterator. It is used to make objects that we can loop through the asynchronous for loop. Think of it like a regular loop, but it can pause and wait for things like downloading data without blocking the program. We use it when we want to process items one by one, but each item might take time to get. After this, we will import the fast MCP library, which will help us create the MCP server. To do that, first we will type from mcp.server, and then we will type fast MCP. Then we will import the fast MCP class. So this is the heart and soul of our system. Fast MCP provides the foundation for creating our database tools. Think of it as the blueprint and construction materials for building our digital database assistant. Then we will import the logging library. To do that, we will type import and then logging. With the help of this, every important event, error, and operation gets recorded. After this, we will import the libraries for PostgreSQL. First, we will enter the try block, and within that try block, we will import the library psychopg2. This is the most popular PostgreSQL adapter for Python. It is like a translator that helps Python talk to PostgreSQL databases. And from the same tool, psychopg2, we will import the extras module to check if it is present. This module provides extra utility functions and classes that go beyond basic database operations. If both of the above lines of code work, we will set a flag called Postgres available and set it to true. This will indicate that the library required to connect to PostgreSQL is available. Since it is available, we will print a message saying PostgreSQL support loaded. And if this library is not installed, we will print a message. First, we will use except and specify the type of error we expect. In this case, it is import error. Inside this except block, we will set the Postgres available flag to false. And then we will print a message saying PostgreSQL not available, SQLite only mode. Now that we have created the code for PostgreSQL support, we will configure the logging operations. To do this, we will type logging basic config, and then we will have a parameter named as level, and we will set it to logging info. We set the label to info because it displays important events without overwhelming detail. There are other logging levels available as well. For example, the debug level shows everything, including detailed internal events useful for debugging. Then we have the warning level for potentially problematic situations, error level for serious issues that prevent part of the program from functioning, and critical level for errors that may cause the program to stop. It's time to create a logger for this module or Python file. To do that, we will type logger logging, then we will write get logger, and then we will pass the name. The name variable is a special Python variable that contains the name of the module or the current file. In this case, it would be database MCP, which is the name of the file without the Python extension .py. Now we are going to build something really amazing, our database manager class. But first, let us understand why we need this. In most applications, we are constantly connecting to databases, running queries, validating data, and handling errors. Without a proper manager, our code becomes a mess of scattered database calls, inconsistent error handling, and security vulnerabilities. What we are building will solve all of that. This database manager class will give us centralized connection management, automatic data validation, SQL injection protection, performance caching, and robust error handling. It is the kind of foundation that makes building database-driven applications a joy instead of a nightmare. First, we will type the class, and then we will write the name of the class, which is database manager, and then we will enter the class. So this creates our class definition. We are calling it database manager because that clearly describes what it does. It manages database operations. Next, we will describe what this class does, which is manages database connections and operations. So this is a doc string, which means documentation that describes what our class does. We should write doc strings right away because it keeps us focused on the purpose of this class. Now let's define the constructor. We will write def and then init, and after that we will provide the parameter self, and then we will provide database type, which should be of type string, and its default value is set to SQLite. Then we will provide database path, which should also be of type string, and we will give the default value as database.db. Now for the comparatively more complex databases that need connection string like PostgreSQL, we need a parameter called connection string, and currently we will set it to, and it should also be a string, but currently we will set it to none, which means null value. Next, we will create the class attributes. First, we will define the database type attribute, and it will receive its value from the database type parameter. To make it case insensitive, we will call lower on it. So we are storing the database type, but calling lower on it. Using the lower is a defensive programming. Whether someone passes the value SQLite in lowercase, uppercase, or with a mix of uppercase and lowercase letters, the lower method will convert it to all lowercase. This ensures there are no case sensitivity issues or bugs. Next line. Next, we will define the database path attribute, which will be set to the value of the database path parameter. This will simply store the database path. For SQLite, this is the file path. For other databases, we might not use this. Next, we will create another attribute called connection string. which will be set to the connection string parameter. This will store the connection string for PostgreSQL database. This will use connection strings with host, port, username, and password information. And after this, we will create another variable called connection. This will be set to none. This will hold our actual database connection object, starting with none because we have not connected yet. Now we will create another variable called max result, and this will be set to 1000. Here 1000 refers to the number of the records the output of the query will show. So this is to prevent runaway queries from returning millions of rows and crashing our application. After this, we will create another variable called isInitialize. Which is set to false. And this is a flag variable that tracks whether we have successfully connected or not. It is crucial for robust error handling. We can check this before running any database operations. And then we will create a private attribute. So we will write self, then underscore table schema. And this will be set to the empty dictionary. The underscore at the beginning indicates that this is a private attribute. We will cache table structure information here so we don't have to query the database schema repeatedly. Now let's create a first asynchronous method which is related to the initialization of the database connection. And to do that, we will type async and then define initialize. We will pass self as the parameter. And inside this, we will create a docstring initialize database connection. So here we have used async at the beginning of the method definition. So what here async means is that asynchronous. And to understand asynchronous, first we have to understand what is synchronous. So synchronous is like a single checkout line at a grocery store. Everyone waits in one line and each person must finish completely before the next person can start. But in asynchronous, it is like having multiple checkout lines open and so that many people can be served at the same time. So everyone gets done much faster. So what asynchronous actually mean here is that instead of doing one task at a time and waiting for it to finish, asynchronous let us start multiple tasks at once and then it will let them all work in the background. And then it will get the results as they finish, but not necessarily in the order in which they are executed. Now we will first initialize the connection to the SQLite database. So to do that, we will type if self database type is SQLite, then we will write await, then self init SQLite. So we will initialize the SQLite database connection with the help of init SQLite method, which we will define in the future. And await keyword will wait for the SQLite database connection to establish. Now we will do the same for the PostgreSQL. We will type else if self database type is PostgreSQL, And if it is the case, then and also we will add if Postgres is available, then we will write await and then we will initialize the connection with the Postgres database. And if the database type is different than the SQLite or PostgreSQL, then we will raise an error. So we will write else, then we will raise an error, unsupported database type, and the value that is provided as the database type, self dot database type. And after that, if the connection is stabilized, we will set the is initialize flag to true as the database is initialized. And then we will create a logger saying database initialized. Then we will provide the name of the database and the path at which it is present. And we should encapsulate this into the try block. So let's do that. We will write try and, and then we will write the accept block and then we will write exception as e and then we will print the error message saying the database is not initialized. So let's do that. Logger error and then have a string database initialization failed and the error that we have got. Then we will set the is initialized attribute to false and then we will raise this error if this method is called. So if there is any error in this part of code in the try block, then this code will be executed. After doing that, we will create another method called define is connected. We will pass self as the parameter and this will return Boolean value. And now we will create the dog string specifying what this method does. It will check if the database is connected and is functional. If the database connection is not initiated, or if the connection is not stabilized, then we will return false. So here we are checking if we are connected with the database or not. After doing this, we will write the try block. Now what we will do is we will create a cursor which will help us execute the query. If we can successfully execute the query, then it means that we are connected, and if we are not able to execute the query, then it means that we are not connected. So let's do that. We will type cursor, we'll type self, then connection dot cursor, then we will type if self database type is SQLite. Then what we will do is we will execute a query. We will type select one. This is the classic database health check. Select one is fast, does not require any tables, and will fail if the connection is broken. Now we will do the same for the PostgreSQL. So let's do that. We will type else. If it is PostgreSQL, then we will write cursor. Then we will type execute, select one. After doing that, we will get the result. And to get the result, we will type result, which is set to cursor. And then we will use a method called fetch one, and this will return one if the connection is stabilized. Then we will close this cursor, and we should always close the cursor to prevent resource leaks. This is crucial in production applications. Now we will return the result, and then we will return the result. We will type return result is not none. So if the result is empty, then it will return false, and if it contains the result, then it will return true. Now we will create an accept block, and then we will write, we also have to add exception here as e, so that we can get the error message. So we will type logger warning, and then we will write the warning message, which is connection test failed for this particular database path, for this particular database path, and we will write the error that we have got. After doing this, we will return false. Now let's create another method called init SQLite. We will type async define init SQLite. We'll pass self as the parameter, and after doing that, we will write the doc string initialize SQLite connection with existence check. So here we will check the connection for the SQLite database. And first we will check if the database file exists. But before doing that, we will pass our path to the path class that we have get from the pathlib library. So let's do that. Self database path. So here the database path is now a object of this class path, and it allows us to perform some operations on the database path. Now let's check if the database file exists or not. We'll write if not database path exists. So we are checking the existence of the file through the path, and if it does not exist, then we will raise an error saying file not found error, and then we will print a message saying database file does not exist. And we will write self database path. So here we have used file not found error because this is error related to the absence of file. And also previously we have used warning here and not error, since this might be expected if the database is temporarily unavailable. Now let's get back to the code. Now we will create the parent directory for the path provided. It is needed if we want to store the log files. So what we'll do is we will type database path and then parent make directory. We'll type parents, which is set to true, and then we will type exist, okay, which is also set to true. So what we are doing here is that we are creating the parent directory for the path that is provided. Here parents is set to true, which means that let's say we have let's say our file is stored inside the two folders, let's say apps, users, and the name of the database, let's say database.db. So our database is inside the two parent directories. One is users and then it is apps. So what this parent set to true will do is that it will create these folders as well. So this will create two folders, apps and users as well. And we have set the exist OK as true, which will check if the directory is already present there or not. If it is already present, then it is fine. If it is not present, then it will create the new directory. Now let's stabilize the connection to the SQLite database. We will type self, then we will type connection, and it is set to SQLite 3.connect. We will type then self, the path of the database to connect, database path, and then we will write check same thread, which is set to false. So what we are doing here is that we are connecting with the SQLite database through this database path, and here we have set this check some thread as false. So what happens is that by default, SQLite connections are not thread safe, and SQLite will raise an error if a connection is used in a thread different from the one that created it. So setting check some thread as false will disable this safety check, allowing the same connection to be used across multiple threads. It is needed for asynchronous applications where the connection might be used from different threads. Now we will create a row factory. Let's do that. We'll type self connection row factory, and then we'll type SQLite row. So here SQLite 3.row is a built-in row factory in SQLite 3 module. It changes how query results are written. Without it, rows are written as tuples. For example, it will be like 1 Alice, which represent the values of different columns, and we can access a particular column's value using a zero-based index. For example, at index 0, the value is 1 in the ID column, and at index 1, it is Alice in the name column. With SQLite 3 row, we can access values by both index and key, just like in tuples and dictionaries, respectively. Let's say we have executed a query and get the result, let's say row cursor dot fetch 1. Now the row contains the result of the query. Without setting row factory, we will get the result through index, like row 0, which could be the index for the ID column, and then row 1, which could be the index for the name column. And with the row factory, which is set to the SQLite row, we can access column values not just by their index, but also by using the column names as keys, similar to how we access values in a dictionary. For example, this. Or if we want to get the name column, then we can specify like this. So this is how row factory works. Now we will do the same for the PostgreSQL. So let's do that. We will type async, and then we will type define init PostgreSQL, and then we will type self, and after doing that we will add the doc string. We will type initialize PostgreSQL connection. Now we will check if the connection string is provided or not. Currently the value of connection string is set to none. So let's write the code to check it. If not, self connection string. So if the connection string is not provided, so what we will do is we will raise an error, and to do that we will type raise value error, and then we will print the error message saying PostgreSQL connection string required. So what we will do is that we will type self, then we will write connection, which is set to psychopg2, and then we will write connect, then we will provide the first parameter as the connection string. So we will write self connection string. And after doing that, we will also provide the another parameter, which is cursor factory, which is set to psycho pg2 dot extras, and then we will write real dictionary cursor. Let's correct this. So what this will do is that it will stabilize the connection with the PostgreSQL server. If the connection string is correct, it means if we have provided the correct host name, password and username and the port number, then it will stabilize the connection with the PostgreSQL. And with this, we are doing the same thing as we are doing before. We are converting the output to a dictionary form so that we will use column name as the key to extract the information. Now we will set the auto commit property to true so that every time we perform any operation on the database, it will save the changes automatically instead of us doing it manually. So let's do that. We will type self and then connection, and then it has a property called auto commit, which we will set to true. Now we will create another method, and this method will give the schema of the table. So let's do that. We will type async define get table schema. Then we will pass the parameter self, create another parameter called table name, which should be of type string, and this will return the result in a dictionary form. So we will write dictionary, and the key will be of the type string, and the value can be of any type. Now let's enter this method, and first we will write talk string. We will write get and cache table schema information. And after doing that, first what we will do is that we will check if the table is already present in the table schema. If it is present, then we will simply return the table schema. So let's do that. We will type if table name is already present in the table schema, and if it is already present, we will return the corresponding schema related to that table. So with the help of table name, we will get the corresponding schema for that table. Now, if in case it is not present, then what we will do is that we will create a try block. So we will type try, and after that, we will write cursor to execute the query. So we will write self connection cursor. So this will create a cursor. And first, we will get the schema for the SQLite table. So let's do that. We'll type if self database type is SQLite, then we will execute a query. We'll write pragma table info, and then we will provide the name of the table. So here we are executing a query, and this query starts with the word pragma. And as we have discussed earlier, pragma is a special command in SQLite that lets us query or modify the internal behavior, settings, or metadata of the SQLite engine or a specific database. We can think of it as a way to access SQLite specific features that are not part of the standard SQL, like turning on specific settings, getting schema info, or debugging. Here, the pragma table info, and then we have provided the table name, It is a special SQLite command that returns one row per column of the specified table containing details such as column ID, which is based on the zero-based index, name of the column, the data type of the column. It will also provide the information that if this column supports the null value or not, and then it will provide the default value that is assigned to this column, and it will also inform that if this column is a primary key or not. Now, after doing that, let's get the result of this query. So we will get columns, cursor, fetch all, and with this we will get the result. Now we will define the schema dictionary. So let's do that. We will write for call in columns. So we are iterating through each column and we will enter this. So what happening here is that we're iterating through the each column. Now we will enter this. Now what we will do is that we will convert each row to the dictionary form. So what we will do is that we'll type call dictionary and we will convert this column to the dictionary type. Because of the row factory setting we configured earlier, the result of the executed query will be returned in a form that allows us to access values either by index, like in tuples, or by key, like in dictionaries. Here we are specifically converting the result to a dictionary to ensure consistent behavior, even though SQLite row objects already support key-based access. And after that, we'll write a schema and column dictionary and the name of the column and the value of this will be a dictionary in which we will have type which is set to column dictionary type, then we will have not null. So type refers to the data type of the column and not null indicates whether the column allows null values or not. And this will be a Boolean column. And if the value is 1, it means that it does not support null values. And if the value is 0, then it means that it supports the null values. So we will write Boolean call dictionary not null. Now the next value will be default value, which is the default value assigned to this column if no input is provided for this column. So let's say default value, which will be assigned as column dictionary, and we will write default value. Then we will create another key, which is the primary key, which will tell if this column is a primary key or not. So this will be a Boolean column. And if the value is 1, it means that this column is the primary key. And if the value is not 1, that is 0, then it means that this column is not a primary key. We will write call dictionary and we will write pk, which refers to the primary key. So our schema will have the name of the column as key and all these values as its values. And if it is not for the SQLite, then we will have to write another one for PostgreSQL. So we'll write the one for PostgreSQL. And what we will do is that we will write again the cursor code. So let's do that. We will write cursor execute, and then we will execute a query. And this query will be like select column name data type is nullable, then column default. Then we will write from information schema dot columns. So in PostgreSQL, information schema dot columns holds all this information related to the columns of the table. Now we will write where table name is equal to percentage or mod s. Mod s is a placeholder for the table name, and we will provide this table name through a variable. And after doing that, we will write order by ordinal position. Now we will provide the table name for this placeholder. We have to provide it as a tuple. So let's type table name, and we will add a comma here. As it is a tuple, then we will get the result columns cursor dot fetch all. And then we will create the empty dictionary for the schema. We will write column in columns. Then we will again convert it to dictionary form, though we have already defined this as real dictionary cursor. This will be written as a dictionary, but we will still convert it to dictionary form just to ensure that it is indeed a dictionary. So let's do that. Call dictionary, write dictionary column. Then we will type schema column dictionary, write the column name as before. Then for this particular column, we will add the values. We can simply copy this and paste it here. And we have to change a few values. For example, here it will be data type instead of just type. And then here will be is nullable. We have to remove this boolean. We can simply compare it with the no. So what this will do is that if the value of the is nullable is no, which means that it does not allow null values, then it will match with this condition and it will return true. So the value of not null will be true, and it means that this column cannot be null. Now we have default value here. So we will change this to column default. And for the primary key, we will set it to false for now because it does not contain primary key attribute. Now that we have got the value of the schema, we will add this value to the table schemas dictionary. So let's do that. We will type self underscore table schemas and then we will type table name which will be set to schema and then we will return schema. Now we will type accept exception as so to find the try block. We have to put it here and now it is correct. And now if there is error in this try block, then we will print an error message here saying logger error will use everything error getting schema for table. We will write the name of the table, which is table name, and then we will print the error message. Then we will return the empty dictionary as the value of the schema. And that was part 2. We have started building our database manager class with the essential methods. Let's recap what we have accomplished today. We have implemented the method for connection testing with proper error handling. We have added the schema caching to improve performance. We have also created proper initialization methods for both SQLite and PostgreSQL. So we have let the groundwork with connection handling and schema management, but our database manager still needs more power to handle real-world operations. In part 3, we will expand our database manager class by adding safe query execution with parameterized statements, data validation and cleaning for insertion, and proper connection cleanup. We will do this in the next tutorial. Thank you. If you need help with your projects, have difficulty learning these concepts, or want to deepen your understanding of how things like this work, Codersarts is here to support you. We offer personalized project assistance, one-to-one live sessions, help with building AI-related applications, and full development and deployment services. Visit us at www.codersarts.com or reach out directly at contact@codersarts.com. You will also find our LinkedIn, Instagram, and Facebook handles linked in the description box below. Thanks for watching and don't forget to like and share the video and subscribe to the channel so you never miss out our latest tutorials. Thank you.